Recorder's going, so hopefully we're good. We're going to do some more equations up here, factoring them. Again, factoring is a major required skill out of this course, because when you get to 111, it's a sub-step in many, many problems, and they hardly review it, much less teach it in 111, simply because they expect you to know it already. Okay? So let's get started on some of these. We'll look at well, first of all, let's do some mental gymnastics. Now, I'm not trying to show off right now. I'm trying to illustrate how my system works so nicely. Okay? Let's look at that number 1 up there. If you think about it, you can factor that one in your head. Let's look at this. Let me turn my pen on first. This thing completely died this morning in class, halfway through. Okay, so anyway, we look at this plus plus. That means we're going to add. These are 1s, so they're not going to really impact us much. 15, the choices are 15 and 1, 5 and 3, right? Do either of one of those 5 or 3 or 15 and 1 add up to 8? The 5 and 3. So this is x plus 5, x plus 3. Okay, this one kind of the same way. We got 1s here, so we don't need to worry about it. 6 and 3 makes 9, so that won't work. What other numbers make 9 and 2? Well, they make 11. So there's your set. X plus 9, x plus 11. Or x plus 2, I mean. What about this one? We know that they're both going to be minuses, and we're going to have to add. We got the 1s again. What 2 numbers that are possibilities of this add up to 10? Add. 12 and 2 makes 14. So what? 5 and 5 don't make 24 though.
6 and 4.
6 and 4. Okay. So m minus 6, m minus 4 on that. You see how easy this can be on some of these problems? Okay. Well, your choices 50 and 1, 25 and 2, and they probably can't see that because it's, I think, in the hot spot. What other possibilities? 10 and 5? Well, 10 and 5 make 15. So this is going to be t minus 10, t minus 5. So that's some of the way that this can really help you to save you huge amounts of time, okay? Especially when that one is a plus right there, because you always just add on those. Now, if you got something besides a 1 up front, that makes it a little more complicated. This one right here, we got a negative, so we're going to have to subtract, okay? So we need 2 numbers out of this that we subtract to get 4. Well, 9 and 5 subtracted give you 4. But we don't know which one's the biggest. Well, actually, we do. That's plus, so the 9's the biggest. Okay. Now, let's go ahead and work that one on the board in full steps. X squared plus 4x minus 45. Okay, we know the answers are going to look like this. And down here, we're going to subtract. We got a 1 and 1 on the front end. On the back end, we got 45 times 1. We also have the possibility of 9 times 5. That's the only ways we can get 45. Well, like we said, the 9 and the 5, here you get a 9, here you get a 5, we subtract them, and we get a 4. Ding. Now, for the rule of signs, this 4 has to be positive. So the 9 has to be positive there. This has to be negative because this is the biggest. So here this sign goes there, and there that sign goes there. Put in the variables, and we got x plus 9 and x minus 5. It really takes the work out of these, especially if there's ones in the first digit. Okay? Okay, number 8. Y squared minus 1y minus 20. Okay, my answer, according to the rule of signs, one of them has to be a plus, one has to be a minus. Now, does it matter which one of these? No, as long, no. So we got 1, 1 here. Our choices are 20 times 1 and 5 times 4. Okay, down here, we're going to subtract. Now, 5 minus 4 is 1. Ding. Rule of signs. That 1 has to be negative. So the biggest one has to be negative. So here's the positive and here's the negative. And put in the x's. And you've got x plus 4, x minus 5. Okay. Well, okay, y. Yeah, y, not x. Thank you. Now you happy? Yeah. Okay. This one looks a little bit ugly. N squared minus 8nm plus minus, don't do that to me, 33m squared.
She was actually trying to get you to change the plus 8m.
Okay.
Oh, yeah.
Oh, it should be a plus there.
Yeah,
Thank
that's
you.
what she's trying to
Okay. Rule of signs says I've got the different signs. I'm going to subtract down here. Okay. Here I've got a 1, 1 on the front end. On the back end, 33 times 1 and 11 times 3. This is starting to look like the one before. Well, except in this case, with the 11 and the 3, here I get 11, here I get 3. These do subtract and give you 8. See, this one had the same first and last numbers as your problem, except had a different middle, so it'll actually work for us. Okay, now let's finish this thing up. Rule of signs. This is plus, so the biggest one is plus. The littlest one is minus. Here go your signs, because that one always goes on top like that. And we put in the N and the M. And the N and the M. Oh, that's an 11, not a parentheses. Okay. So my answer then is N plus 11M and N minus 3M. Okay. This one is a perfect square. The answer on this one is C plus 5 quantity squared. Look at rule A. Rule A. Perfect square on the front, perfect square on the back, okay? And for this middle, it's 2 times the first term times the last term. So 2 times 5 times C is 10C. Okay. Number 13. This is the first one we've come to that doesn't have ones in the front. So we're going to have to work a little harder on that. Question, somebody? I thought I heard someone speak. Just moaning in agony, right? All right, so 5x squared minus 55x plus 140. My answer will look like minus minus. Down here, I'm going to add. Okay. Well, my only possibilities on the front end are 5 and 1. Back end, I got a huge amount of possibilities. I got 140 times 1, 70 times 2, 35 times 4. Let's see. 28 times 5. 28 times 5. Yeah, that'll work. 14 times 10. And 7 times 20. I think that's all the possibilities. Okay. So I've got same signs, so I've got to add, but I've also got this multiply by 5 thing in here. And I got 55. So probably won't be either one of these two. Unlikely it would be this one. Now, I'm going to try this one. And I'm going to put it this way. Whoops. This way. And then I'm going to put this here. Okay. Why am I putting the 7 down here instead of up here? Because I need a 5 when I multiply. Okay, that's my thinking. Well, anyway, here I get a 20. Here I get a 35. I add those and I get 55. So my answer then is just simply x minus 7 minus and then the x there. And here, 5x minus 20. Okay. How would you like those numbers to have to deal with the AC system? You multiply them and get those big, large sums. Okay. All right, let's look at 16 now. What's different about this one than any other one we've done?
All the numbers have variables. All of them are variables, and all of them have attributes.
Since all of them have variables, we can probably factor out a variable before we start. Okay? I'm teaching you to look for strategies. That's what I'm trying to do anyway. And maybe or maybe not, we can do anything with the numbers. In this case, we got p to the 4th minus 10p cubed minus 11 p squared. Well, I can take a p squared out of all of those. So my final answer is going to look like p squared times this times that. And after I take this out, I've got p to the second minus 10p minus 11. Rule of signs says I'm going to have different signs. So down here, I'm going to have to subtract. Now, I'm just going to bring this thing down to my final answer, okay, or my final answer. Now we need to factor this thing. Well, I got a 1, 1 here. And 11 minus 1 makes 10, right? So 11 this way, 1 this way. We subtract them when we get 10. Rule of signs then, that's negative. So this is negative, the biggest is negative, the littlest is positive. And here go the signs. So we've got, well, it's p's, not x's. P minus 11 and p plus 1. Okay. So that's an instance where we have to factor out something first. If you look at my sheet right here, what is the very first line? Look for common factors to take out of everything. Okay, that's why that's in there.
So we could have done that with 14 as well. By taking 7 out of it. Yeah,
actually we could have, and it would have saved us some time. We could have factored the 7 out in the beginning. The 7 will go once here, and 7 will go 12 here, and 7 will go 20 there. And so actually our final answer on that other one had something that wasn't completely factored, because it had a 7 that could be divided out. I don't remember the answers I had before. What answers did I have last time?
We skipped 14.
Did we?
Yeah.
Oh.
We went from
okay.
14 to 16.
Okay.
Oh, we did.
Oh, yeah. Oh, yeah. Okay. Oops. All right. Let's jump down to 22. 3y squared plus 16y plus 5. Okay, we're going to add down here. Our answers are going to look like plus plus. Okay. 3 and 1 is the only possibility here. 5 and 1 is the only possibility here. Well, I need to put the 5 here, so when I multiply, I get a 15, and then a 1 over here, so I get a 1 and 15, and 1 makes 16. You look a little puzzled on that. Well, hey, then you need to stop me way back there. Seriously. Stop me when you don't understand. Then, not later. So where do I need to show you?
Oh, right. This is the last equation you worked on.
Let's go with this one. Is there anything in this one you don't understand so far?
No.
Okay. Well,
no.
Okay,
The
so
last one.
You know, these are both pluses, and you got your x's here to get your answer. Okay, let's go back to the previous one. No, don't be. Next time, just ask it then, not later. Okay, which one were we talking about?
I think it was the
16?
Yeah.
Okay, p fourth minus 10 p cubed minus 11 p squared. And the first thing I did was factor a p squared out of everything. Okay, now are you good that far? Okay. This I'm just going to bring down to my final answer. And the rule of signs on this says one's going to be positive and one's going to be negative. You okay with that? That's a negative. Okay. Now, 1, 1, because there's a 1 in front of that. Your only choices here are 11 times 1 and which order we put them in. Well, because we are having different signs, we have to subtract. Anytime you have a negative sign here, you have to subtract. If you have a positive sign there, you have to add. Okay, now, I got the 11 and the 1. I multiply these two and I get 11. I multiply these two and I get 1. I subtract them and I get 10. Okay, are you with me so far? Okay. The only thing left is how to determine which sign goes with which. That's a negative. Okay, so this one has to be negative because what you're doing is you are matching this to that. Now, since that's a negative after you subtract it, the biggest of these two has to be a negative. Well, if they're different signs and that one's negative, then this one has to be positive. Positive always comes here. I mean, whatever this sign is always comes here. Whatever this sign is always comes here. So we put our p's in here, and I get p minus 11. And I get p plus 1. And then I've got this p squared on the outside times the whole thing. Now, is there anything in this that you don't understand what I did or why I did?
No, I think I did it.
Don't just say that.
No, I'm trying to think about how I can integrate that into the problem.
Okay, well, let's try another one. Okay. Which one?
Sorry, oh, 4x or x to the 4th power minus x squared plus 25.
Which one are you on?
Not on there.
Okay. X to the 4th.
Minus x squared. Or 10x squared, I'm sorry. Plus 25.
Okay, I'm getting ahead of where I'm wanting to be in the lesson right now, but I'll go ahead and do that. This is a number out of the homework. 67B. There are two ways you can work this problem. Okay. The two ways you can work this problem. If this power is twice as big as that power. Now that's the key for one of the two ways. Actually, both of them. Okay. This power has to be twice as big as that one. This one has to be twice as big as that one. Well, what? There's a 1 behind that 25. Okay, our power. Now, you can factor this thing. That, by the way, is a perfect square. It's x minus 5, except instead of x minus 5, it's x squared minus 5, x squared minus 5. If this was a 2 and that was a 1, or just an x, wouldn't it factor to do without the squares? Okay. What?
What do you do with that x?
X squared times x squared is x4.
Okay.
Yeah, I'm not doing the cross product thing right now. I'm just factoring this way. You can do it this way. Okay. Now, you could get to here by doing the cross product thing. Okay. Except you're just going to have squares instead of first powers. Now then, now's where it gets a little complicated. In this case, we're going to have trouble doing a little bit more because we don't have an equals anything. Okay. Now, the other way that you could work this problem, we can't really finish this one. Now, I bet on the problem you got there, you got equal 0 out here. No? Okay. All right. So if we take this, we can say u equals x squared. We're doing a substitution. Okay. So then using this, if u is x squared, then I've got u squared minus 10u plus 25. Okay. Now, this thing factors, it's a perfect square. 1, 1, 5, 5. You're going to add, and down here you get 25. Excuse me. Multiply, you get 5. You multiply, you get 5. And you're adding, and you get 10. Okay. And in this case, we know everything's got to be minus. So you got u minus 5 and u plus 5. Okay, or minus 5. Okay, now, if I take this and I substitute x squared back in where the u was, then I've got x squared minus 5 and x squared minus 5. Or simply x squared minus 5 squared, quantity squared. Okay. Now, we can't get this down all the way without an equal 0 on the end. And we will come to that, just not yet. Okay. But here's two ways of doing this. You know, basically I did this same process of using the 1 and the 1 and the 5 and the 5 to get this. Yeah, this is just a faster way to do that. If you can, as long as this is double like that.
So on the test, if it's a perfect square, do you want us to write like quantity squared, or do you want us to do?
Quantity squared is actually the simplest way to express it. So that would be the preferred way.
Okay.
Now, am I going to count it wrong if you have x plus 5, x plus 5? Probably not.
Okay.
But I would prefer you have x plus 5 quantity squared.
Okay.
Okay. Okay, so we've done this one. Of these remaining 5 problems, I'll do 2 of them.
You should do 29.
I should do 29. Which other one?
24.
24. Okay. 7p squared minus 15 plus 2. My answer is going to have to look like this. Minus, minus. Okay? Now, in this case, 7 and 1 is my only choices. This tells me down here I'm going to add. My only choices here is 2 and 1. So how can I get a 15? Well, if I take 7 times 2 and 1 times 1, here I get a 1, here I get a 14. They add up to 15. Okay? That's got to be a negative. So the biggest has to be negative. The littlest has to be positive. Here's the negative, here's the positive, and we put the p's in there.
They're both
But they're both negative.
Oh, okay. Yeah, we added, didn't we? Forget that. You don't have to re-sign these if they're both the same sign. Although you can. That's a negative. This is a negative. That's a negative. That's a negative. That's a negative. Everything's a negative. Okay. So we have 7p minus 1 and p minus 2. You see, it's easy to make little mistakes. Even though you're working it the right way, you still make blunders. Okay. And we'll work 29 now. Negative 6x squared minus 19x minus 10. My rule of signs tells me I'm going to have this. So down here somewhere I've got to subtract. I wonder if you... Now, I want a positive number right here. So I'm going to factor negative 1 out of everything. Like so. Now the rules, which count now, are both the same. And I'm going to add. So factoring out something can materially affect everything. Now, we're going to break these down. Here I can have 6 and 1 or 3 and 2. Here I can have 10 and 1 or 5 and 2. So I got potentially 4 different possibilities. Well, I'm going to try, and I'm going to be adding, so I can't use real big numbers. I'm going to try the 6 and 1 here. I could be right, I could be wrong, I don't know. I'm going to try the 5 and 2, and I'm going to put them this way. Because if I had the 5 on the bottom, I'd have 30 already. It's too much. Okay, well, here I get 5. Here I get 12. I add those and I get 19. Ding.
That's
17.
Ooh.
Yeah, that's not enough.
And okay, well, obviously that didn't work. Let's try something different. I really don't think, well, let's try the 10 and 1, but I certainly can't put the 10 here. If I put the 10 there and the 1 there, here I get 10, here I get 6. And that'd be 16, so that doesn't work.
What about 3 and 2 and 5 and 2? Yeah.
3 and 2.
5 and 2. 2 on top.
2 on top, 5 on the bottom. Okay, so here I get 15, here I get 4, and that makes 19. You know what? What I heard you guys just doing is what I want you to do, where I wanted you to go, where I wanted you to get. Okay, where you can look at these combinations and see where they can come up with that middle number. Okay, if you're doing that, then you're going to be successful on this. Okay. Now, all of that said, let's go on.
So what would that be in the parentheses?
Now that I've erased it.
Be 3x plus 2, 2x plus 5.
Okay.
I lost a negative in front of the, not the
Now I got all these little circles up here to nowhere.
Yeah, and then with a negative final answer. So
You do have to put the numbers actually.
yes.
You do.
Otherwise you'd end up otherwise your final would end up being 6x squared plus 19.
Okay, what did I get down here? We had 3 and a 2,
And then a 2 and a 5.
and a 2 and a 5. Okay, and these were all pluses, right?
Yeah.
Or were they all minuses?
All pluses.
Okay, plus, plus, x, x. So that gave me this and this, but I had previously taken a -1 out of everything. So your final answer then would be -1 times 3x plus 2, 2x plus 5. I got in too big of a hurry and didn't show the rest of that.
If you don't put the -1, all of your signs will be swapped when you do.
Now, is that wrong?
No.
Is it the most simple it can be? No. This is the most simple it can be, but that is not wrong. In other words, this is if I didn't take the negative out. Likewise, if I had 3x plus 2 and I had -2x minus 5, there being the negative on that one. That also is not wrong. It's just not simplest. Okay. Now, I don't want to spend a whole lot of time on these. Work 1 or 2 of them. So look at them carefully and see which ones scare you the worst.
Number 8.
Number 8.
Number 8.
That one?
Yeah.
And what else one? 18. 18, that one? 10.
We did green.
Now we're going to do 2.
Okay, then 8 and 10.
8 and 10. Okay. And by the way, I would consider both of those problems very ugly. Yeah. 81 x squared plus 99x plus 28. Okay, this thing is going to end up with potentially a plus plus. Okay. Okay, well, we've got 81 times 1, 27 times our 27 times 3, 9 times 9, right? Over here, 28 times 1, 14 times 2, and 7 times 4 are the possibilities. Well, I'm going to try the 9 first, simply because they're both the same, so it won't make any difference which order they're in over here. Okay. Usually, I try some of the middle ones, not necessarily the biggest ones. Very seldom will it be the biggest ones, although it can be. Now, I'm going to add, and I'm going to get 99. 9 times 10 would be 90 by itself. So I'm probably going to use either one of these two. So I'll try the 7 and the 4. 7 times 9 is 63. 4 times 9 is 36. We're going to add 9, 9. Ding! Okay. Now, did you understand my reason on why I tried the 7 and 4? Because these other two, if I multiply it times 9, would give me too big a numbers. Okay? So I did a little bit of elimination there, okay, in my head. Well, what does my answer look like? 9x plus 7, 9x plus 4. All that big nasty thing to come down to looking something no worse than that. Okay, now you wanted number 10. Anybody want to reconsider that to something that has a negative on the end? So we have to use different signs? I mean, I'll do. Yeah. This one's just going to be minus minus.
20 is a minus.
20 is a minus plus. But if you want to do 10 instead, I'll do it. 7. Yeah, 7 looks pretty nasty. We'll do 7. 45x squared plus 46x minus 63. Oh. Well, anything go into all three of those first. 9 and 5 here are 3, 3, 5. 46 is just 23 times 2. And 63 is 9 times 7. So nothing will go into all of them. You really do need to consider stuff like that. Okay, so 45 and 1, 9 and 5 are the possibilities. I'm going to try 9 and 5 first. Down here, of course, I'm going to subtract because of the different signs. Okay, 63 and 1. 9 and 7. I suppose 3 and 21. So those are different possibilities. Now, what do we do? We're going to have different signs, so we're going to subtract. So we're going to have a fairly big number minus a smaller number to get 46. So what if I use the 9 and the 7 and put the 7 there and the 9 here? 9 times 7 is 63. 9 times 5 is 45. If I subtract those, it's bigger than 46. So I'm not even going to go. Okay. Well, 21 times 9 minus 15, that isn't even a possibility.
3 and 15.
For the 45.
For the 45.
3 and 15.
Oh, okay. Yeah. You know what? I bet it's that. Okay, now, what do we want to try with this? Try with 9 and 7 again. Okay, here, 5, carry 3, 7 and 3 is 10, minus 27, way too big. Okay, so that won't work. What if I had the 21 and the 3 here? That'd be 45. This would be 63. Still won't work.
Yes.
9 and 5 here.
9 and 5 and then 7 and 9. So you have 12 and 9.
And 7 and 9 this way.
Yes.
81 and 35. 11 minus 5 is 6. 7 minus 3 is 4. Dean. Now, let's put the signs in. This one's got to be a positive. So the biggest is got to be a positive. There's the negative. Here goes the positive. Here goes the negative. Put in the variables. So 9x minus 7, strange looking 7, and 5x plus 9. That one was kind of a bad nest. Oh, sorry, I hit my hand. Okay, let's continue on. I want to get a couple other things covered. Okay, you've seen these rules. We used this one to this morning already, or this afternoon, evening, whatever this is. Okay. Oh, looky what I got. Now, to use these rules, let's consider some things. Before you can use any of these first 3 rules, you have to have a perfect square on the front and a perfect square on the back. Perfect square on the front, perfect square on the back. Perfect square on the front, perfect square on the back. You must have that as a condition for even possibly using this shortcut rule. Okay? Now, again, we got the 2 times first times last and the minus 1 on the minus. And this is the conjugate pair, which is the opposite signs. And we'll talk about these 2 a little later. Looking at number 6, is it a candidate for that shortcut? Why? Because 12 is not a perfect square. Okay, what about number 3? No, because 2 is not a perfect square. Okay, that's not a perfect square. That's not a perfect square. There's a perfect square. Perfect square on the front, perfect square on the back. But they're opposite signs. And there is a middle term, so rule C won't work with this one. Okay? Well, I don't have any perfect squares on this page. And that's really what I'm wanting to cover with you, but I might have some on this page. And here are some more of those where you can use that U squared trick. Okay, where you can use the, here you can factor out 2R out of everything. This one you can factor out 5R. This one you can factor out 2y squared. Right? Okay, this one, you can factor 3R out of it. This one, you can factor x cubed. Okay, here you can factor out x cubed again. Here you can factor out 3y squared. Here you can factor out 5y squared. Okay, And after you do some of these things are going to get a whole lot easier. Here you can factor out 4x squared. Okay. So that kind of goes with that rule number 1 on my sheet. Okay, we look at these. We can factor out 100 out of all 3 of those. Okay, so you got to look for those things, is the point I'm trying to make. Okay, all right, so we're not going to use the AC method, we're going to use the C method. Yay. Okay, we got to factor this thing. Well, I guess I got to work it. Rats. 10x squared plus x minus 3. Okay, nothing will factor out of the whole thing. I got 10 and 1, 5 and 2. I'm going to try 5 and 2. Okay, 10 and 1, 5 and 2. Over here, I got 3 and 1. Is the only choices. Now, I'm going to subtract, and I want to end up with 1. So I probably don't want the 3 and the 5 multiplying together. So 3 and 1 this way. Here I get 5. Here I get 6. 6 minus 5 is 1. Ding. Rule of signs. That 1 has to be positive. So the biggest is positive, the littlest is negative. Here go the signs, put in the variables. Now we got this one. Isn't this just the problem with your variables? Negative 4wz cubed minus 2w squared z squared plus 20w cubed z. Notice that as the z's went down, the w's went up in pattern. In powers. Okay, that'll usually happen. Well, I can take a 2 out of everything. I can take a negative out of everything. I can take a w to the first out of everything. And I can take a z to the first out of everything. So I can take a negative 2wz out of everything. What does that leave me? That leaves me 2z squared plus wz, one of them, minus 10w squared. Okay? Based on this, my rule of signs then down here, and I've got this minus 2wz down here that I'm just going to bring down. Based on the rule of signs, one's got to be positive, one's got to be negative. So that means somewhere here I'm going to have to subtract. 2 and 1 is my only choice on the front end. I've got a choice of 10 and 1 or 5 and 2 back here. So let's try 5 this way, 2 that way. Here I get 5, here I get 4. They subtract and I get 1. Ding. That 1 has to be a positive. So the biggest is positive, the littlest is negative. Here's my signs. Here's my variables. And in this case, it's Z's here, W's there, Z's here, W's there. So my answer is this stuff brought down times 2Z plus 5W and 1Z minus 2W. And there's your answer. Okay. Okay, this is just more of this, and we're not going to do those. I need to move on. Okay, perfect square ones, that's rule A and rule B. Factor completely. Perfect square on the front, perfect square on the back, 6 times 6, right? 2 times 6 times 1 is 12, right? So the middle matches. So this thing factored then is just simply that. Okay, what this business is they're trying to tell you what I spoke out. The 12 is the 2 times the x times the 6. Here, we got the first term squared, the last term squared. Okay. Okay, what about this one? Perfect square on the front, perfect square on the back. The factors are 1 and 1. 2 times 1x times 1 is 2x. So that one factors. Okay, what does it factor to? It factors into x plus 1 quantity squared. Okay, this one, perfect square on the front, perfect square on the back, both in letters and numbers. Now let's check the middle. The first term here would be 4x. The last term here would be 9y, right? So the middle term, we would need 2 times 2x, which gives us now 4x, times 9y, and 4 times 9 is 36, and the y. Well, let's look at this. 36, the -2, okay? Because it's a negative there. And then the first term, if the first term is squared, then it would be 2x. And then here, it would be 9y. So the first term squared, 2 times the first term times the last term, plus the last term squared, does in fact match that. So here's our answer. First term minus last term, quantity squared. Do you have to use this? No, you can still factor these the other way. Okay, but this will save you some time if you learn to use it. Perfect square in the front, perfect square in the back. 3 times 2 is 6, times 2 is 12. Okay. and then x or yz. Did you see how I thought that one? Square root of 9 is 3, times square root of 4 is 2, so 3 times 2 is 6, times that 2 in the middle term gives you 12, because you have a pair of them. Okay? Factoring by substitution. This also can be called factoring, factoring by substitution. You've got some of these in your homework problem as well, homework problems. Well, here, in this case, you remember the problems where we had x to the fourth and x to the second and a number? How we use u equals x squared? You remember that just 10 minutes ago?
Yeah.
This is kind of the same thing, except we're treating this whole parentheses like it was a number or a letter. So we're substituting that whole parentheses for u. Well, what does that do? Then that gives you this equation. U squared minus 3 times u minus 40. This we can factor pretty easy, right? It's going to have a positive and a negative. We factor the thing down, and it ultimately will factor to this. I'm not going to show the factors. So this factors into that. Now what we do is we go replace this u with 2x plus minus 7. Just like earlier, we replaced the u with an x squared or a y squared or whatever it was. So here's where we replace the u, minus 8. And here's where we replace the u plus 5. We can simplify that. We don't really need that parentheses. So you get those, and those right there will simplify to this. And if you multiply these two together, they'll multiply out to that original equation. Okay. Whoops, went too far. Well, anyway, that's the original one. All we're doing is we are temporarily replacing that parentheses with a u, factoring it, and then putting the parentheses back in. Okay, and apparently they can factor a 2 out of something. Here, they can factor a 2 out of both of those. All right, here's another one. Okay, factor by substitution. We've done some with fourths and seconds. Notice this is double that. So we're going to let u be y cubed this time. Always the smaller one. Okay, so we do that. That gives us 6 times what would be that squared. But we're just going to put the u's in there because we're substituting the u's for the y cubes. This we can factor. You're going to have different signs, and ultimately it factors down to this. Okay? Now we have to replace these u's back with the y cubes we had to start with, which gives us that and that. And for the sake of this problem, that's as far as we can go. Okay, I want to go on. These are just some general rules for this. Okay, here's rule C. Rule C. Okay, perfect square in the front, perfect square in the back, minus in the middle. That's going to give you 4x plus 3, 4x minus 3, a conjugate pair. Guess what the middle term on this one is if you want to factor it the other way? 0x. Okay. Factor this one. That's not a perfect square, and neither is this. But you know what? 2 will go out of both of those, and so will D. And when you factor 2D out of this, you do have a perfect square on the front, a perfect square on the back, a minus in the middle. So then we can take that parentheses and break it down into 7C minus 5D and 7C plus 5D, which I said that just backwards to the order they've got them here. And then you got the 2D out front. And that's as far as you can go. Here's another one. Perfect square on the front, perfect square on the back, minus in the middle. Now there's a gimmick in this one that you got to be careful about. This one is showing something new. Now, this thing can factor into z squared minus 9, z squared plus 9 if you want to do it that way. Or you can do it by substitution. Okay. Either way, I wouldn't use the substitution. I just half that power and take the square root of that. Okay. Now, this won't break down with a plus in the middle. But that one will. That's still a conjugate. Perfect square in the front, perfect square in the back, minus in the middle. So this piece with the minus will still break down farther. With the square and the minus, it'll still break down. With the square and the plus, it won't break down. Okay. So be alert to this, because I promise you I'm going to have one of those on my test in the final. How far back?
No, I can't see it.
Oh, when I moved is what you're asking. Oh, I'm sorry.
Question for you.
Uh-huh.
Never mind.
Okay.
I answered my own question a bit after I was getting ready to ask it.
You want to share what your question was?
I was going to answer.
was.
I was going to ask. Not really, because it's going to. It has possibility.
Okay.
No.
Sorry, I was going to ask if you could substitute, if you could factor out -1 out of the z squared plus 1. But you can't, because then the z squared.
To answer your question, it still wouldn't help you.
Right, because the z squared would be negative. Right, it'd be negative at that point.
Okay.
What?
Oh, I need to back up to this. Nope, not that. There we go. Squares with a plus in the middle is not factorable. We have to use other methods. Okay, which will be that one. But that is not factoring. Squares with a minus in the middle is factorable. Okay, so this piece is prime, is what I'm saying. Now, once we start putting equals 0 or something on the end, then we can deal with it. But right now we can't. Okay, by grouping, there's some of this on your handout. Okay, by grouping, notice I have 4 terms. To be grouping, you got to have 4 terms. Usually, the first one will be a cube. Does not have to be. I can have a square and 2 x terms or y terms here, instead of 1 of y squared and 1 of y. Okay. Now, if we want to factor that one, then what we are going to do is we're going to group some of these pieces together. We're going to divide this problem in half right down the middle. To this part and that part. And you do have some of these on your handout sheet. Not a lot of them, but you do have a few. Okay. Now, can I factor anything common out of this?
Y squared.
Y squared. Okay. Can I factor anything common out of this?
4.
-4. So if I factor y squared out of these two, and I factor -4 out of those two, I've got that thing, right?
Mm-hmm.
Now, look at this. Here's the magic. You've got common terms you can pull out. Except this common term is a whole parentheses. Okay? So we pull those out. What does that leave us? Y squared -4. Okay? Now, are we done?
Probably not.
I've got a conjugate here, don't I? So this will break down farther into y +2, y -2, and then I've got this one that I just bring down. Okay?
I've got a question.
Sure.
What do you do about y squared at the very back or the front?
Right here?
Down.
Here.
On the third line.
Here?
To the second.
It goes to the second parentheses. These two factor out. Okay, consider this. What if I had y squared times x -4 times x? I'm pulling out the x. And what have I still got left? Y squared -4. That's what I did. Okay. I need to erase my scribbles. And there it's going to show you what I finished up. Except they just showed that you had to finish factoring. Okay, here's another one. Another one of these. This one's a little weird. Well, let's look at this one. Look at that. Look how we broke this one out. Now, is there anything we can factor out of this? Huh? -1. Okay. Can we factor that? Perfect square on the front, perfect square on the back. That one's going to be y +3, y +3. So I've got this 6 square minus hidden 1 times that factored parentheses. Okay, yes. Okay.
I thought the middle, if you have this square in front and then back, middle, that'd be it.
What?
I thought, yeah, put the square in front and put the square in back.
You're confusing two things. You're confusing rule A and rule C. Okay, rule C, I wouldn't have had this middle term. Okay. But rule A or B, then I've got that 2 times first times last thing. Did that answer your question? Okay. All right, now, what is this nonsense down here? Huh? Believe it or not, this thing is a conjugate right there. That thing right there by itself is a conjugate, which gives you first term minus last term and first term plus last term. And that looks kind of complicated. Now we can combine these into just one simple parentheses like that. And ultimately, if we distributed this x and then that y, negative y, and then that negative 3, we would come out with this answer. Say again. Where? Here is your conjugate, your plus and your minus. Okay, what if we replace this with a? X squared minus a squared. Then you would have x minus a and x plus a. Okay. This one is just taking those and simplifying them together. Okay. Well, that's where we're going to stop. So have a good evening.